Okay, exam 1, problem 2. So an automobile starts at rest and accelerates at 2 meters per second squared for 10 seconds, then decelerates at 5 meters per second squared until it comes to a stop. Question A is, how fast is it going at the 10-second mark? Well, this problem is really two problems, right? There's the problem part, the first part where it's accelerating, and then the second part where it's decelerating. And part A is, how fast was it going at the end of the first part? Okay, so part A. Part A. So we have V equals AT plus V naught is the equation we should be looking for here. That's the velocity equation in one dimension under constant acceleration. We have the acceleration, we have the time, we have the starting velocity, which was 0, right? It starts at rest. So the velocity is 2 meters per second squared times 10 seconds, right? Plus 0, the initial velocity. So part A, the velocity is simply 20 meters per second. All right, 20 meters per second. All right, part B. How long did it take for it to come to a stop? Now, in part B, we're at a different segment of the problem. So for part B, what's the initial velocity? The initial velocity in part B is now 20 meters per second. It's where we ended the previous segment of the problem, right? What's the final velocity? Final velocity is 0, all right? What's the acceleration? Acceleration is 5 meters per second squared. And what do we not know? We don't know time. So we have V equals AT plus V naught. But in this instance, right? In this instance, that is 0 equals 5. All right, oh, back up a second. The acceleration is negative because we are decelerating, right? Minus 5 meters per second squared times the time plus the initial velocity, 20 meters per second. 20 meters per second. So this means that the time is 20 meters per second divided by 5, if you go through the algebra, 5 meters per second squared equals 4 seconds. The time is 4 seconds. Now, part C. Part C is, how far did it travel from start to finish? Okay? So let's look at the first part of the problem. In the first part of the problem, we have x equals 1/2 AT squared, right? I'm going to label these x1, and a1, right? x1 and a1. The initial velocity, the first part of the problem, is 0, so that's going to go away, and the initial position at the first part of the problem is also 0, right? So we're left with x1 equals 1/2 of, what was that acceleration? 2 meters per second squared. 2 meters per second squared, right? Times 10 seconds. 10 seconds squared, right? So that is 100 meters, right? Because 2 times 1/2 gives us 1, 10 squared gives us 100. So in the first part of the problem, it goes 100 meters. How far does it go in the second part of the problem? x2 equals 1/2 a2 t squared, right, plus v naught 2 v naught to t plus x naught. So we can, in fact, call this x1, right? Since we're starting from that position. We know how much time it was. It was 4 seconds. We know that A2 is this minus 5 meters per second squared, right? So we have x2 equals minus 2.5 meters per second squared times 4 seconds squared, right? That's how long it took to stop in the second half of the problem. Plus, what's the initial velocity? The initial velocity is 20 meters per second times 4 seconds. Plus, what's our initial position? 100 meters. Okay. So, equals minus 2.5 times 4 squared plus 20 times 4 plus 100. It's 140 meters. And that 140 meters is the total distance traveled by the car during the course of accelerating and decelerating as described up here. And that's the answer to part C, and we're done.